Hello, my name is Rob Reynolds. Welcome to Mat-073. Today we're going to be discussing our third section. We're in the middle of discussing how to solve systems. The first section was by graphing. The second section was by substitution. And in this third section we're going to look at the elimination method, or sometimes called linear combinations. So we're going to try to eliminate either the x's or the y's and solve for the other variables. So for example, we have to try to determine what's easiest to eliminate here. So if we were to eliminate the x's, we would need a negative 4x so that when you add, the x terms will drop out. But in order to do that, you have to multiply both sides through by negative 4. Maybe a better strategy is to look at the y terms, because the y terms look like they already are set up to eliminate if you just add. So we're just going to add straight down and get 5x is equal to 15. So x is 3. And again, all we have to do, kind of like the substitution method, is just take this 3 and either plug it into line 1 or line 2. It's your choice. I would choose line 2 because the numbers look a little bit smaller. So instead of saying x minus 3y equals 7, I'm going to take this x value and plug it in there, which is a 3. And if I subtract 3 from both sides, I'll get negative 3y is equal to 4. And the y value then is negative 4/3, which doesn't look like a nice answer, but actually that is correct. You can go and actually check that. Again, I solved this by equation 2, so to check it, you might just want to quickly throw this into line 1. Since this was generated from line 2, let's go back this answer to line 1. So 4 times the 3, the x value, plus 3 times the negative 4/3, and I would probably just take a calculator, punch that in, and see if that's really equal to 8. That should check. Here's the author's version of how they worked this out. Looks like they got the same answer. You could spend the time to graph these, but that's really not the point. Linear combination is the method of choice here. So the first example was pretty nice because all we had to do was just add and the y terms eliminated. So the hard part is probably getting this started. So look at the x's. To eliminate the x's, you'd have to choose maybe a negative 3 to multiply through the top equation and maybe a positive 2, because that would give me a 6x here, or excuse me, a negative 6x here and a positive 6x here. That might be the best option. Another option would be perhaps to look at, instead of eliminating the x's, we could try to eliminate the y's. And maybe that's a little bit easier because I don't have to multiply both line 1 and line 2. It looks like to eliminate the y's, all I would have to do is multiply both sides by 2, because I think that will give me a 10y here, which will eliminate with this negative 10y. So I'm going to rewrite the top equation. If I distribute 2 times the 2x is 4x, keep distributing throughout every term, 5y is equal to negative 2. This term here. I'm just going to rewrite this bottom equation, and now it's kind of set up like the first example. If I add straight down, I think those y terms will just eliminate, which is fantastic. So 7x is equal to 14. X turns out to be 2. I'm going to take this 2 and choose either line 1 or line 2. I would always go back to the original. Don't use any equations that you may have created in the process. So I'm going to go back to line 1 just because I'm more afraid of that 16 than I am that negative 1. So 2 times the x value plus 5y equals negative 1, and I'm going to plug that x in here. So 4 plus 5y should equal negative 1. And finishing this off, I'll subtract 4 from both sides, giving me negative 5, and y equals negative 1. Again, one of the strategies for checking is, since I generated this with line 1, and I know that that was line 1 because that negative 1 matched with this negative 1, then the strategy is, let's check it with line 2. So line 2, I'm just going to take this point and see if 3 times 2 minus 10 times the negative 1 really does equal 16. This side I don't even need a calculator for. It looks like it's going to work pretty good. 16 equals 16. So now I'm convinced this is a solution. And again, this is how the author worked it out, and looks like they got the same solution. So if it's not in standard form, ax plus by is equal to c, maybe my first goal would be to get it into that form. Sometimes it makes the problems just a little bit easier. As I'm getting into the form, I'm thinking, well, either I need a 6x, or for the comment, or I need a 15. And since 6 is smaller than the 15, I think I'm going to go for the 6, because no matter what method, I'm going to have to multiply both the numerator and the denominator. So I'm going to go for a 6 because it's smaller than the 15. And going for a 6, I'm going to multiply the top by -3 and the bottom by a 2. So I think that will generate that, well, in the numerator I've got a 6x, and for line 1 I've got a 6x, and for line 2, so this is my 6x, which I love, and this will give me my, so it's kind of dreaming what you want to happen and then forcing it to happen by multiplying both sides by whatever it takes. So let's distribute this to every term. Let's distribute this to every term. So -3 times the 3y is -9y. Minus 6, because that's the 3 times -2. Over here, I got the 6x. This is equal to, let's distribute this 2. 10y plus 8. So it looks like when I add, I get 0 equals y plus 2. So y better equal -2. And again, it looks like I'm half done, but I'm a heck of a lot more than half done, because I've done all the hard work. All I need to do is determine if I want to go back to line 1 or line 2. And again, I would always go back to the original equation. It doesn't really matter. I'm going to choose line 1. So instead of writing 2x equals 3 times the y value plus 2, I'm going to take this as the y value, and it says y equals -2, so I'll plug that in right here. And if y is -2, 2x is equal to -6 plus 2, 2x is equal to -4, and x equals -2, and I'll plug that right in here. Again, here's how the author chose to solve it, and it looks like we have the same solution. You can check that. So again, I call it the I have a dream lesson. Either you could dream about eliminating the x's or eliminating the y's, and the common denominator between the x's is 2, the common denominator between the y's is 1, so I'm choosing the 1. It's just smaller. And I can do that by multiplying through by a -1. So I'm going to rewrite the top equation. Line number 1 becomes -2x plus y, if I distribute to every term, equals -1. And I'll just rewrite the bottom equation because it looks like my y terms then will cancel by adding. It's interesting though, the x term also cancels, so I get a big fat 0 on the left side equals -4, which of course is a false statement, and that means that there is no solution. So remember, no solution means I have two parallel lines and it's inconsistent function. So if you end up with a false statement, there's no value for x and y that would ever make that statement true. Likewise over here, I'm going to look at trying to eliminate either the x's or the y's. To eliminate the x's, the common denominator between 3 and 9 is 9. To eliminate the x's, I could go to 12. So again, I'm choosing the smallest number because I usually do better with smaller numbers. So I'll multiply the numerator by -3. What that's accomplishing is I'll give me a -9x for the numerator, and that will cancel with this 9x in the denominator. So finishing out, distributing the -3 gives me a -12y and a -15. And in the denominator, I just rewrite. And look, if I add, I get 0 equals 0. Instead of a false, this is a true statement, which means I have infinitely many solutions. This is a dependent system, which means one line falls onto the other line. So a true statement gives me a dependent, and that means every answer from line A is also an answer from line B. If I could have drawn that line right on top of the other line, I would have. So look at the graphing method if you'd like to see some examples of that. So again, some strategies. Try to write it in the standard form. Clear any decimals or fractions by multiplying by common denominators or powers of 10. Choose a variable to eliminate, and I always go for the smaller. And you can read through these steps of suggestions of how to solve. Remember, if it's false, it's an inconsistent independent function. That means that you have parallel lines. And if it's a true statement, that means we have a consistent dependent where one function lies on top of the other, and I have infinitely many. So up here, there is no solution. And down here, I have infinitely many, because every point on this line, which there are infinite many, is also a point on the other line. So these answers are exactly opposite each other. So a couple word problems before we close out the video. We've learned that the perimeter definition is twice the length plus twice the width. And it says that the perimeter is 268. So I'll write it. Twice the length plus twice the width is 268. Continuing reading, I've got some more information here. It says the length is 30 feet longer than the width. So the length is means the length is. So I'll write it. I'm translating English into a math equation. To go 30 feet longer than the width, it's kind of like adding 34 to your age. You need some age before you add the 34. And I would write it backwards like this. Even though the 34 is mentioned first, before the width, I would write the width plus 34 because it just makes more sense to add 34 to something. So you need something first before you add the 34. Then, since the directions don't say solve this by linear combination, I'm going to revert back to the previous section, which is the substitution method. And the substitution, because this is set up beautifully for substitution, and we'll put it into this form. If you have to show this, if the directions said use linear combinations, then I could do it by writing it as twice the length plus twice the width equals 268. And all I would have to do is subtract off this w. So the length minus w is equal to 34. And then maybe I could just multiply the bottom equation through by 2 to eliminate some variables. I'll just continue with this since this is the lesson. It looks like substitution is better. But if I multiply everything through by 2, I'll get twice the length, twice the width, and this 34 goes to 68, doubling everything. So this is 4 times the length is equal to 336. And if I divide through by 4, I'll get the length is 84. Once you determine that the length is 84, I can plug that right back in here. Nope. That's wrong. Let's plug it in for the length. The length is 84. So 84 is equal to the width plus 34. So to solve for the width, I just subtract off 34 from both sides. So the width turns out to be 50. Again, I would not write it as length comma width because I don't know if you're doing length width or width length. I would just leave the answer by defining the length and defining the width. Here's how the author chose to work it out. But again, see how they leave the answer. The length is 84, and here it is. The width equals 50. In fact, I think they even write it out pretty good here. So one last one. Wilt Chamberlain once scored 100 points, setting a record for points scored in the NBA. Chamberlain took only 2-point shots and 1-point foul shots. And made a so the 2 points for the X's for the number of shots that he took on the field, plus 1 point for any free throws that he made would be the total points of the game. And it looks like they scored 100 points in the game. Now, let's reread this because it looks like there's some more information here. 64 is given. Oh, he took 64 shots. So we don't know how many shots he took from the field, and we don't know how many free throws he took, but we do know that X plus Y is 64. And one of the strategies is instead of saying X and Y, well, we could define. X is the number of shots that you're taking from the field, or from the court, and then Y would be the free throw shots. So That way we know that's why I'm doubling, because he gets 2 points from anything from the court. So, oh, this looks like a good problem to solve by linear combinations. I wouldn't use substitution here. It looks like I could eliminate very quickly by multiplying the bottom equation through by a -1, which in essence just changes all of the signs. So negative x minus y is equal to negative 64, and I'll just keep line number 1 the same, because adding, it will eliminate the y terms. So x is equal to 36, and then I'll substitute that x back into either equation 1 or equation 2, and since I've kind of already messed up equation 2 already with a -1, I'll just go to equation 1. So twice the x value plus y better equal 100. So twice 36 is 72, and if I subtract off 72 from both sides, I'll get 28. So again, instead of leaving the answer like 36 comma 28, you might want to write out in words what the 36 means and what the 28 means. So 36 2-point shots and 28 foul shots. I hope this video was helpful. Email me with your questions. Thanks.